Okay, this is sections 8.4 and 8.5. We're going to cover these together because they are so very similar. So, all right, my printer is, I don't know, it's busted or something. It's not printing right. It's not the ink either because I've, checked that and that's fine. I think the drum needs to be cleaned, or I don't know, maybe it needs to be taken out in the backyard and beat or something. I don't know. It's old. So anyway, this did not print out. This, I assure you, this looks much nicer on the scanned copy that is linked in D2L for you guys. But as always, we will do the best we can with what we can. So what I did was I typed up these examples because normally in class I would just give this out so you don't have to write down the word problems. So I'm just going to reference this and then go over to the notes and show you the work for them. All of these will be scanned together for you though. All right, so Carmen invested $9,000, part in a 6% passbook account. A passbook account is just a savings account. That's just another name for a savings account. And the rest in a 10% certificate account. That's like, you may have heard those called CDs before. If her annual interest was $680, how much did she invest at each rate? All right, so here's what we got to do. We have to figure out how to set up a system of two equations and two variables, and then solve those using substitution or elimination. Okay? So the only new part here is setting up the system of two equations and two variables from the given information. All right, the solving, we've done that in the previous sections. So here's what we're going to do. I'm going to let P equal the amount invested at 6% because it was the passbook. Right? I'm going to let C be the amount at 10% because that was the certificate or the CD. Okay? The difference being that a passbook account or a savings account, you can withdraw money out of it. A CD, that certificate account, you cannot. If you put it into a CD, you do get a higher yield out of it. However, you can't touch it for a certain amount of time. There's different kinds of CDs. There's like 6 months, there's a year, 3 years, things like that. So anyway, the total money, it said that she invested a total of $9,000. So in math terms, the total money is P plus C is 9,000. The total interest she earned was $680. Now, if you look at this, you may be wondering, why do I have decimals? Because you cannot work with percents. When you're doing computations, you cannot work with percents. You do have to change those to a decimal. So, this right here is the same as 6%. So in order to do these computations, you got to write these percents as decimals. Now, here's the thing. A percent means out of 100, right? Percent. Per divided by. Cent, 100. Divide by 100, right? So the word is telling you what to do. Also, have you ever looked at the symbol? Look at the symbol for percent. Look closely here. All right, you guys got like a helmet or some saran wrap or something like that? Because I am about to blow your mind. Are you ready for this? Are you watching? Don't be zoned out. If you're asleep, wake up. Look, see that slash right there? Looks like a division symbol, doesn't it? See those two little zeros? Oh, look at that, 2 zeros and 100. I'm going to give you a second to process that. Because I know, that's kind of wicked, isn't it? That's awesome. So, anyway, 6% is 6 out of 100, or 0.06. 10%, 10 out of 100, or 0.10. I always put a 0 before my decimal points because I was brainwashed in my chemistry classes to do that by a very nice Indian man who yelled at me repeatedly if I did not do it. So, thank you, Dr. Prakash Bahara, for instilling that into me. So, now we get these two equations. Two equations, two variables. Just because I need to pick something and stick with it, most of the time when I teach this in class, students tend to like substitution more. So I am just going to, bump this camera here and make it all janky. I'm going to go ahead and just use substitution for all of these. If you feel more proficient with elimination and you'd rather use that, go with it. Okay, we should all get the same answer in the end no matter which way we go. But just for consistency, I am going to use substitution. All right, so I'm going to take this top equation and I solved it for C. So if you ever see my little double arrow here, that's just my way of saying that this equation is equivalent to this equation. I don't like using an equal in between because, you know, I don't want it to get confused with that equal sign, so I'll use a double arrow. All right, so I get this top equation solved for one of the variables, and then I'm going to substitute it into the bottom equation. So my bottom equation is about to change. All right, so here's substituting that. Got a lot of examples here. There's a big old packet here to go through. 14 pages. That's okay. We'll go through it. All right, so substituting that in, we get this. We're going to distribute that 0.10. So we're going to multiply it through, combine the like terms, and then solve. Now at this point, okay, I am going to kind of speed up a little bit on this equation solving. I am still writing out all the steps for you. However, I'm not going to explain it, you know, as in detail as I did in the previous ones. Okay, so I'm going to assume at this point that you guys are okay with this equation. Now, if for some reason you do get stuck in here, you can always take a screenshot of this or take a picture of this and say, hey, I got lost in this step. Email it to me and I'll be glad to explain those details to you. Okay, but just for the sake of these videos not being 2 hours long, I'm going to just kind of skip over a little bit of these details. Okay, so in solving this, we get P, the amount at the passbook account, that was the 6% account, is $5,500. Just like before, to finish the problem, we do plug that back into the thing that we substituted, and that was that 9,000 minus P. All right, so subtracting those off, I get that the certificate amount was $3,500. That was the amount at the 10%. If you wanted to use X and Y, you certainly could. I tend to try to use variables that are descriptive so that I know which one's which. If I use X, I'm being like, oh, which one was X and which one was Y. So I try to use letters that will help me remember which variable stood for, you know, which account. Okay, so next up we have example 2. On 2 investments totaling $9,500, Darius lost 3% on one and earned 6% on the other. If his net annual receipts were $282, how much was each investment? Ugh, this one's really messy, okay? Because of the loss and the earn, this one gets really messy. All right, so once again, I'm going to start off by identifying my variables. I chose to use X and Y for this one, okay? But I did write out which one's X and which one's Y, so I can always refer back to that. So it does tell me that the total investments, right? The investments totaling $9,500, so I know that equation. And then we have the total interest. Now this one's very similar to the last example, but look, see how I got that negative right there? Why do you think that negative is there? Well, that's because he lost that 3% on that investment and then gained the 6% on the other one. Yeah. This camera's all kind of wonky looking. Got pointed a little too far down. Okay, that looks a little bit better. You guys may not notice. Okay, so remember, I'm using percents here. 3%, 3 out of 100, or 0.03. So these are percents. So there's my 2 equations. I took the top equation because it's the prettier one, and I just solved it for Y. I just subtracted over X. I could have just as easily, solved for X, but I just chose to solve for Y. And then I substituted this into the other equation. So my bottom equation now becomes this. I am going to distribute that 0.06 throughout here. Okay. this is where you might want to pause the video because I am going to speed up a little bit throughout this equation solving process. You then combine like terms, move the constants to one side, variables to the other, divide by that coefficient. So we get that x is $3,200. That was the amount at 3%. All right, that was the amount that he lost. Now, the y value, remember this, where we had the substitution? I'm going to plug that x into there, and I get 6,300. That was the amount at 6%. If you forget which one was which, that's why I wrote it at the beginning. That's a good habit to get into, so that you don't have to remember, and you don't mess up by putting the wrong number. Because Hawks is going to say, okay, here's the amount at 3%. How much is the amount at 6%? It's going to have those labeled, so you want to make sure you get them in the right, boxes there. Okay. Example 3. All right. GFA invested some money in a development yielding 24% and $9,000 less in a development yielding 18%. If the first investment produces $2,820 more per year than the second, how much is invested in each development? All right, so let's get going on it. So we've got example 3, and here is my dog scratching on the door again. She wanted out, she wanted in. I swear she's part cat. All right, so we've got this x is the amount at 24%, and the y is the amount at 18%. Again, labeling these is very important. All right, translating these into equations is not as easy as examples 1 and 2. So I want to go through this in detail for you. So the original problem said the amount invested, sorry, that's an abbreviation for amount, invested at 18% is $9,000 less than the amount invested at 24%. That translates to this equation, okay? The amount invested at 18%, that's y, is, there's the equals, 9,000 less than. The words less than mean subtracted from. So less than is 9,000 subtracted from this number. So here's the equation that results from this sentence in the original problem. All right, the next sentence says the first account, that's the 24% one, produces $2,820 more in interest per year than the second. Okay, so we're talking about interest. That means that we need percents. All right? So the first, the 24%, here's the interest on the 24% account. It's 24% of the amount in the account. Okay? And that one is or produces $2,820 more than the second account's interest. Here's the interest on the second account. It's 18% of that number. If you forget to put these variables on here and you just put 0.24, you're saying that 24 cents and 18 cents. You do need to have those variables because it's 24% of that amount. Remember that of typically means multiply. So there's my two equations. So that's why I put those little arrows on there. So there's my two equations. I'm going to use substitution. This one's already set up for substitution. See, it's already solved for y. So I'm going to substitute that into there. Using substitution, this bottom equation becomes this. I'm going to distribute that 0.18 throughout there. These constants are like terms. I'm going to then move that x term over here. So pause it at any point if you need to take a little extra time on this equation solving stuff. Then last step, I'm going to divide by that coefficient of x, and I get x equals 20,000. Remember, at the beginning, x was the amount at 24%. Y, going back to the substitution part of it, I'm going to plug 20,000 into here, and I get 11,000. 20,000 minus 9,000. If at any point you get something like, say, negative numbers, then you've done something wrong. Okay? If you're talking about amount of money that's invested, it's going to be positive. If you're talking about, say, like the length of a side of a swimming pool, it's going to be positive. So think about your answers and whether or not they make logical sense. Okay. Now, I tried to start off with examples 1 through 3 because I felt like they were a good lead-in into this section. Okay. Examples 1 through 3 were from section 8.5. So when you go to do the homework, just know that that's 8.5. 4 through 9, those are going to be from 8.4. All right, let's see. Flip this over to example 4. The sum of two numbers is 36. 3 times the smaller plus twice the larger is 87. Find the two numbers. All right. The word sum means add. So the sum of two numbers is 36. All right. The next sentence said 3 times, there it is, 3 times the smaller number. And I just said, hey, let's call x the smaller and y the larger. So 3 times the smaller plus twice the larger is 87. There's my two equations. I took the top equation and solved it for y. And then substituted into, oops, pencil just yanked that over. That was abrupt. Sorry about that. So, and then I'm going to substitute that into that bottom equation. So that bottom equation then becomes this. You guys know the routine by now, right? We're going to distribute that 2. Feel free to pause the video at any point too and like work ahead of me before you see the answers. Don't just watch and think that, you know, everything's going to be great. You do have to be able to do this on your own, okay? If you guys were going to learn a sport, you wouldn't just like watch it, right? You wouldn't just be like, hey, I watched the gymnastics part of the Olympics. I'm a gymnast now. You're going to crack your skull and die. So yeah, math's sort of like that. You do have to practice it. You can't just watch. I wish you could just watch and learn, because that'd be pretty awesome. All right, so combining those like terms, you know, and then subtracting over those constants, we get 1x equals 15. We know that 1 doesn't have to be written. And remember up here I said x was the smaller number, so that's my smaller number. Going back to my substitution here, I'm going to plug that x value of 15 into that and get a y value of 21. Remember, y was my larger number, so there's my larger number. All right, example 5. They're getting a little tougher as we go. I started with the money because I thought maybe those might, you know, kind of appeal to you a little bit more before we get into the algebraic kind. Example 5, the length of a rectangle is 10 meters more than half the width. If the perimeter is 44 meters, what are the length and the width? Or what are the dimensions? All right. So first sentence says the length. So look, the length is, there's the equals, is 10 meters more than half of the width. So do you see how I read that in English but wrote it in math? The length is 10 more than half of the width. Cool, right? All right, if the perimeter is 44 meters, remember perimeter is the distance around. Look, in the word rim, as in like edge, the distance around the edge. You add up all 4 sides. So I have a little picture drawn here for you. The perimeter is length plus width plus length plus width. You can simplify that into 2L plus 2W. So these little arrows are pointing to my 2 equations. Here's one equation, here's the other that I'm solving together. Already set up for substitution, right? So I'm going to plug this mess in right there. All right, by now you should be tired of looking at it, of the substitution, because we've seen it so much now. We're going to distribute that 2, combine like terms, move that constant over, and divide. So I get W is equal to 8. That's my width is 8 meters. To find the length, I am going to go back up here, and I'm going to plug in this answer of 8 right there. So I'm going to do 10 plus half of 8. So 10 plus half of 8 is 10 plus 4. That gives me a length of 14 meters. Example 9. Wait, where's example 9 here? What do you mean, example 9? Did I miss something? I skipped something. We're already at 9. I need example 6. I don't know how 9 got over there. Oh well. So example 6 here. Here we go. Usain Bolt, the world record holder in the 100-meter dash. Although I'm not sure after these last Olympics, is he still the world record holder? I don't know if he is or not. I thought I remember somebody breaking his record, but then there was like some doping issues. I don't know. Anyway, at the time this was written, Usain Bolt was the world record holder in the 100-meter dash. He ran 100 meters in 9.69 seconds with no wind. He later ran the same distance in 9.58 seconds with the wind. That means the wind was at his back. It was helping him along. So what was his speed and what was the wind's speed? All right, so we know that distance is rate times time. Rate is the same thing as speed. So he ran 100 meters with no wind. He ran that in 9.69 seconds. All right, so that's just a simple division problem here. So his speed with no wind was 10.32 meters per second. All right. Now, with the wind, we have distance is rate times time. So this one is with the wind at his back, or with the wind assisting him. 100 meters in this time. So if I divide that out, I get that his speed was 10.44 meters per second. Now that was his speed with the wind. So how do you find the wind speed? Well, it's the difference between these, assuming that he ran the same rate, okay, that he was just as fast with both of them. So the wind speed is going to be the difference between those two. So that would be that 0.12 meters per second. Now I pulled this one out of Hawks because I felt like it was one of those where you might try to make it a lot more complicated than it is. You know, it kind of has that feeling like it's going to be, complicated. You really don't have to set up two equations and two variables. And if you can get away without doing that, I will. So I'll show you those cases when that happens. Okie dokie, moving on. Okay. Sorry about the little cutaway here. So I had example 9 kind of out of order, and I was like, oh, that's confusing. Why did I do that? And then I remembered why I did that. Because this setup was very similar to the previous ones, and it really should have been earlier, so I just kind of jumped over to do that one. So let's go ahead and jump over to example 9. I know it's out of order, sorry about that, but let's jump to example 9, just because the next ones all have to do with distance, rate, time, and this one doesn't, so I really should have put it earlier. Anyway. So 70 children, 160 adults attended a play. The total receipts were $620. One adult ticket and 2 children's ticket cost $7. Find the price of each type of ticket. Can I just tell you how much I hate these kind of problems? They're just, I don't know. I feel like we can do better. I feel like we can make like more realistic problems than this, but yeah, so I finished typing up the examples, and then this one showed up in Hawks, and I was like, oh, I should do one like this too. So I added it to the end, and I shouldn't have. I should have put it earlier. Anyway, rambling done. Let's let A be the price of an adult ticket and C be the price of a child's ticket. The total receipts, the total amount of money collected was $620. That means 70 C plus 160 A is $620. That's because it says 70 children and 160 adults. So each kid paid C dollars, okay, because these are dollars. And each adult paid A dollars, so 160 times A would be the total amount collected from adult tickets. Now, it says that one adult and 2 child's tickets cost $7. So there's my 2 equations. You guys know the drill. I'm going to take one of them and I'm going to solve it for a variable and substitute into the other. So looking at this bottom equation, I'm like, yeah, I'll solve that for A. And then plug it into the top equation. Now, here's the thing. I was like, I'm just going to leave it to you guys to finish. And then I came back and I thought better of it. I was like, all right. I was going to leave it for you guys to do. And I thought, no, maybe I don't. I forgot to come back and wipe that out. Sorry about that. Oh well, we all make mistakes. You guys see me making mistakes, you forgive me. I see you guys making mistakes, I forgive you. It works. The top equation then becomes this stuff. We're going to distribute that 160 throughout. Zoom, zoom, zoom. We get all this equation business, we get C equals $2. Substituting that 2, right, up here. And for C, we get that A is $3. So the child's ticket is $2, the adult ticket is $3. So, oh my gosh, why does my dog make all these crazy noises when I'm hitting record? Are you okay, little beagle girl? Are you okay? Oh my goodness, poor girl. Okay, so I'm going to make a little note here that this is intentionally out of order. So in case you guys are looking at these notes later and you're like, what happened? Is she, addicted to crack or something? No. I assure you I'm not. I'm just a hot mess here. That's what happens when you're me. Okie dokie, let's go on. Example 7. We got 2 more examples. We got 7 and 8. And these are going to be those distance, rate, time problems. You might remember these from such hits as Math 90. Randy made a business trip of 190 miles. He averages 52 miles per hour for the first part of the trip and 56 miles per hour for the second part. Total trip takes 3.5 hours. How long did he travel at each rate? So if you want to pause the video to get a better read on that, you can. All right, so here we go. We're going to let X be his time for the first part and Y be the time for the second. Now, how did I know to let it be time and not say rate or distance? Well, because it says how long did he travel at each rate? So that's what I'm looking for. How long? Time. So there's the time for the first part, time for the second part. The total time of the trip was 3.5 hours. So I wrote it as this. I chose to not use the fractions. I chose to use the decimal here. You can use fractions if you want. The total distance. So that's what usually happens with these equations, is that you need some kind of total, be it like total amount of money invested, total interest, total receipts, those kind of things. You'll see that word total used a lot. The total distance traveled was 190 miles. All right. The first part of the trip, how far did he go? Well, the distance for the first part is rate times time. Distance for the second part, rate times time. The difference is that the rate and the time are different. So we get rate, the first part he traveled 52 miles an hour for however long. The second part of the trip, he traveled 56 miles per hour for however long. And that gave me the total distance. So this one, once the setup is complete, it's not too menacing, but there is, a good bit of work involved in getting that set up. All right, let's solve that top equation for y and then plug it into the bottom equation. So by solving that top equation for y and substituting into the bottom equation here, we're in familiar territory. By now you guys are experts at substitution. Combining our like terms, moving that constant over, then we're going to divide by -4 to solve that for x. Remember, x was the time for the first part of his trip. Now, how do you know that? Because I wrote it right here for you. Going back to the substitution and then plugging that answer in, we get that y is 2 hours. That's the time for the second part of his trip. All right, last one here is example 8. We got Naomi and we got Linda. They lived 324 miles apart. They start at the same time and travel toward each other. Naomi's speed is 8 miles per hour greater than Linda's. If they meet in 3 hours, find their speeds. Pause the video if you need to read that and digest it a little slower. All right, so here's a picture of what's happening. We got Naomi over here, we got Linda over here. Total distance between them is 324 miles, right? The total time each one of them's driving is 3 hours, okay? Because they're going to meet up in 3 hours. Now, where are they going to meet up? Well, they're going to meet up somewhere in the middle. How did I know it was here? Because Naomi is driving 8 miles per hour faster. So she's going to travel farther in that 3 hours than Linda will. Okay? So here's how I set it up. I chose to not use 2 equations and 2 variables. That's why I wanted to do an example like this. Okay? I chose to set it up like this so that I didn't end up with 2 variables. So I said, hey, this is r plus 8, that one's r. So whatever her rate is, hers is 8 miles per hour greater. Hawks would have set this up as Linda's rate is x, Naomi's is y, and so one of them's like x plus 8 equals y. I just chose not to set it up that way. Now, the total distance is 324 miles. So, much like the last example, Naomi's distance, rate times time. So there's Naomi's rate. They each drive 3 hours. Plus Linda's distance, which is rate times time. Remember, Linda's rate was r, and they both drove for 3 hours. Gives you the total distance between them. I'm going to distribute that 3. Combine those like terms. And we never have to do substitution or elimination because I never introduced a second variable. So I get that r is 50 miles per hour. Now it says find their speeds. So r, and how did I know that was Linda's speed? We'll go back up here and look at my drawing here. Linda, I said was r, Naomi was r plus 8. So that's Linda's speed. So Naomi's speed was at r plus 8. So her speed is 58 miles per hour. Now remember, these are going to be realistic measures. So if you're doing this and you get that Linda's traveling at, say, 500 miles per hour, maybe you need to go back and check your math because you probably missed something somewhere in there, okay? Okay, at long last, with much snarfy from my beagle and much mistakes from me, we are done with sections 8.4 and 8.5. I know this was a really long video. Thank you for staying with me throughout it. I hope you enjoyed it as much as you can enjoy word problems. So, all right, that concludes sections 8.4 and 8.5.